In the early 20th century, Albert Einstein was deeply troubled. Newton's laws of motion and gravitation had ruled physics for centuries, and though immensely successful, they didn't account for everything. Einstein knew that something was missing, a deeper truth about how the universe works. Newton's theory explained that gravity was a force pulling objects towards one another. But Einstein saw inconsistencies. If this force traveled instantly, how could it affect something light years away? He imagined something more profound, that space and time themselves might not be as rigid and unchanging as Newton thought. He believed that gravity wasn't just a force, but rather a warping of space and time by mass and energy. Einstein began to develop a new theory, which he called general relativity. His idea was revolutionary. Massive objects like planets and stars bend the fabric of space-time, and other objects move along the curves created by this bending. Essentially, what we perceive as the force of gravity is actually objects following curved paths in this warped space-time. But could this wild idea really be true? To test his theory, Einstein realized it needed to explain something that Newton's theory couldn't. One such puzzle was the orbit of Mercury. For centuries, astronomers had known that Mercury's orbit wasn't quite what Newton's laws predicted, but they didn't know why. Einstein showed that his theory perfectly explained this anomaly. Mercury's orbit was influenced by the warping of space-time near the Sun. The most famous test came in 1919 during a solar eclipse. British astronomer Sir Arthur Eddington led an expedition to measure how light from distant stars bent as it passed near the Sun. Einstein predicted that the Sun's gravity would bend the starlight, causing the stars to appear in slightly different positions than expected. When the eclipse came, the results were astonishing. The starlight had indeed bent, exactly as Einstein had predicted. His theory was correct, and in that moment, the world realized that space and time themselves could bend and twist under the influence of gravity. The discovery of general relativity overturned centuries of scientific thinking and cemented Einstein as one of the greatest minds in history.